Hello everyone, Storm11 here. Today we'll be talking about a storm system that's going to bring in a severe weather outbreak across most of the south. Possibility of a derecho. That derecho could also bring the widespread damaging strongline winds. Several tornadoes, with one or two of those could be strong, and maybe some small hail as well. But as you get further south here, both focused in the parts of Louisiana, Mississippi, and Alabama, storms may become a little bit more of a broken line storm, so minimal supercells, those will have the better potential to produce stronger tornadoes as well. And this severe weather risk could last in the parts of the mid-Atlantic down to parts of Georgia and Florida as well. Thursday. Before we get started this video, if you guys like weather-related content, you can subscribe to my channel. We do this stuff here all the time on this channel. Plus, we'll have another update or two on this severe weather setup as well, so definitely stay tuned for any more updates on the storm setup as well. We're going to get started with the watch warning advisory display. Things are getting busy out there. One of the more noticeable things, you see all this brown out here? These are wind advisories, and it covers a large area, covering multiple states across parts of the East Central U.S. as well. These are areas that could experience wind gusts anywhere from 40 to up as high as 55 miles per hour. And you got these lighter brown shades here. You got one in southern Louisiana and one in the parts of New Mexico, Texas, that does extend into parts of Kansas as well. Those are high wind warnings where we could potentially see wind gusts at least 60 miles per hour. That's going to lead to a significant fire weather risk as well for some of these areas, which is not a good thing at all for them tomorrow. We also got a severe thunderstorm watch in effect for parts of eastern Nebraska, southwestern Iowa that extends into eastern Kansas, northwestern Missouri, parts of Oklahoma, even into parts of Texas as well. That's the ongoing severe weather event in some of those areas as well. Otherwise, things are getting active. We also do have, almost forgot, winter weather advisories for northeastern Minnesota down to parts of the Ohio Valley. That's where that warm front will begin to pass, and that could lead to a mix of some snow and maybe some freezing rain as well as that warm front does begin to pass. That could cause some issues on the roads as well. This is the outlook for tonight from the Storm Prediction Center. Got a slight risk for severe weather from central Texas that goes all the way up into a good chunk of Iowa and eastern Nebraska. The greatest tornado risk looks to be anywhere from northern Texas all the way up into eastern Kansas and far western Missouri, where we do have a 5% area. Damaging winds and hail looks to be your primary threats as well at this time. Tomorrow, there is a large moderate risk for severe weather. This includes far eastern Arkansas, parts of eastern Louisiana, pretty much the entire state of Mississippi, parts of western Tennessee, western Alabama, and the far western panhandle of Florida. And then got the enhanced risk that goes as far north as southeastern Missouri, far southern Illinois, and southwestern Kentucky. That gets as far east as central Tennessee, eastern Alabama, and parts of the Florida Panhandle, and does go as far west as central Arkansas and western Louisiana. The tornado threat is there. You got a large 15% risk for tornadoes across parts of southern Mississippi, southwestern Alabama, the far western panhandle of Florida, and also for central and eastern Louisiana as well. With that hatch area, that's where we could potentially see some significant tornadoes, which is EF2 or higher. Damaging winds looks to be the primary threat with this setup here. That extends all the way up into western Tennessee. And with that hatch area, that's where we could possibly see hurricane force winds as well. There may be some hail for these storms, but really it's not a big threat. And then on day 3, which is Thursday, you got 2 slight risks. You got one for parts of the Mid-Atlantic. You got another one for parts of Georgia in the Florida Panhandle as well. Right now, Thursday's not looking to be a big day or anything for both of these areas. Kind of staying on the lower end risk side here. The main threat up in the parts of Mid-Atlantic looks to be damaged winds, but there could be a couple spin up tornadoes as well. But as you get to the other slight crest further south here, I think the primary threat is going to be damaging winds down there as well. Otherwise, Thursday, for right now, it doesn't look to be too big of a deal of a day. So if we check out the current environment here, we're actually going to first start off with surface-based cape. This is important when you kind of check out some models, which we'll compare the Hermel and the Harvest NAM to what's going on. So right now, it's 0Z for right now. And right now, we have instability values widespread, 1,000 plus. There's even a sliver of 1,500 across parts of western Oklahoma into southwestern Kansas as well. So that's a pretty good amount of cape. But if we compare it to other malls, now we're going back to earlier this morning, 6Z. And you can see here from the HER model, yeah, it's definitely lacking on the instability. Where we had the 1,500 instability, it's not there. Pretty much anywhere from 1,000 to 1,200 joules per kilogram. It's not as widespread. And you should get further north here. It's a similar situation, especially in east central Kansas, where we have at least 1,000 joules per kilogram, and it's only showing about 600 joules per kilogram of cape. So really, overall, the Hermos is underestimating instability, and that's not always a good thing, especially for the upcoming event tomorrow. Hieronym is actually much closer, but it is still lacking on the instability further south here, but it is doing a little bit of a better job than Hermo. But you also notice it's also a little bit slow here, actually too slow. Actually, yeah, it's a little bit too slow with this one, and the Her model is actually much faster. So there are some differences here with the performance with the Her and Harvest NAM. Harvest NAM is closer to instability, a little bit better, but it's also a little bit too slow. Her model is a little bit too fast, but it also doesn't have as much instability as well. And really, overall, this kind of tells you that the models tomorrow are probably going to underestimate as well. I checked out temperatures out of southwestern Kentucky earlier today using the Kentucky Methodist stations. The Hermal is the closest, but still off by a degree or two, which could still make a decent difference when it comes to instability. And the Hiersdale was off by like 5 to 10 degrees. I mean, it was well off. It had mid 60s, and temperatures in reality were closer to the mid 70s. So really, anytime we have warmer temperatures can increase your instability. That's basically what I'm saying here. And I think that's going to be a similar situation for tomorrow as well. So that's the reason why I really want to point that out real quick, is that these balls here are probably going to underestimate those instability values for tomorrow, which if we check out instability, now this is mixed layer cape. It's a little bit different, but it's a more accurate way to kind of look at it, which if you actually check out mixed layer cape currently, let's kind of backtrack a little bit. Let's not get too far ahead of ourselves here. So if we check out a mixed layer cape, which is a more accurate cape to kind of look into, this is where it becomes more convective for thunderstorms. Pretty much similar to a surface-based cape here, but usually mixed layer cape does last longer. It can go deeper into the overnight hours as well, last longer than surface-based cape. But sometimes it's not as high as surface-based cape. That's something that should be noted as well. Downdraft cape, there's some decent numbers out there. Could be enough for some damage and winds. But when you check out low-level evaporates, it's actually on the strong side, which can help with that damage and wind threat. The mid-level evaporates is also a little on the stronger side too, which can lead to stronger updrafts, which can lead to a large hail threat. And how much wind shear we got here? There's a decent amount of wind shear out there. Really above 150 would be favorable for severe weather. There's some areas where we got values up to 400, which is pretty high. And we could see similar numbers like that tomorrow for some other areas, so it could be much higher than that when it comes to wind shear values tomorrow. If we check out the significant weather parameters using the fixed layer, which is a more accurate tool to use, anytime where you're over 1, conditions could be favorable for tornadoes, but where you're over 2, conditions could be favorable for stronger tornadoes. Which there is a very tiny area of a 2, but I don't really see strong tornadoes out there. There's actually 2 areas. You got a very tiny area in southeastern Nebraska, and there's another one in southern Kansas. So really, I don't think we're going to see strong tornadoes out here, but the conditions are at least favorable for tornadoes out there as well. So that's something as well. But let's begin to check out some models. Let's now move to tomorrow, the more significant day. So if we check out Big Slayer Cape, and again, like I said earlier, it's a more accurate way to look into instability. And you can see here, we got some pretty decent numbers out here. You got anywhere from maybe about 400 to close to 700 in some places. Now you would think some of these numbers are not high. Think about this again. You're talking about an environment that we got tons of wind energy in the setup here. If you remember me talking about the wind energy in the last video, you will know this, that some of the numbers here, or wind speeds, especially at 700 and 850 millibars, could reach new record wind speeds, especially in the parts of Tennessee and Kentucky. So the amount of wind energy that we have on the setup is ridiculously high. And that's also leading to a forcing of a squall line to develop as well, where we have very strong lift out there. So it doesn't take much instability to get strong severe storms going. Really, if you see 100 joules per kilogram, as low as that, you can still see strong storms. I mean, that's the type of environment you're talking about. And if you have Big Slayer Cape up to 600, I mean, conditions could be favorable for significant severe weather. So it's not going to take much instability to get significant severe storms to get going. That's really for damaged winds. But for a bit farther to the south here, we're going to see more discrete mode. A little bit further south here, there's actually some better instability values down here as well. And then again, like I was saying earlier, the these models here are probably going to underestimate these values here as well. It will not surprise me at all. And that can actually increase your severe weather potential as well, which is pretty concerning as well. And here's the higher end when it comes to Big Slayer Cape here, which was a little bit closer to what we have currently. You can see here, it's higher with those Big Slayer Cape values. It's not very high as you get further to the north, though. If you actually go to earlier in the day, there's actually some decent values as far north as southern Illinois as well, which is interesting. And you will see higher numbers as you get closer to the Gulf Coast as well. And the higher Dam does have a pretty good environment for severe weather as well. Something should be noted here that the difference between the Harris NAM and the HER model is much lower when it comes to dew point values compared to Harris NAM, which actually it did verify. Currently, we actually have low to mid 50 dew points in a parts of central Kansas right now. Meanwhile, the Harris NAM it's got low 60s, and dew points are not even close to there. And when it comes to tomorrow's setup, the Harris NAM was much more aggressive here, especially in these areas right up here where it actually had upper 60 dew points to close to 70. But with the HER model, which got the dew points pretty much spot on, it's only showing upper 50s to low 60s. So that really makes a big difference because with higher dew points, that can make the atmosphere more unstable. But with lower dew points, now upper 50 to low 60 dew points can still be favorable. But the difference here is that with higher dew point values, that the instability values will likely be higher, but lower dew point values can have lower instability values as well. So that's something I should note as well. And checking out the Hermon when it comes to dew points, you can see here along that squall line, it's even got 60 dew points all the way up into central Illinois as well. And right behind this is your squall line. This is where it's located as well, which we'll check out reflectivity here in a little bit to show you guys what it could look like. But I kind of want to show you the ingredients first here to kind of show you what we could be dealing with here. But regardless here, it still shows a pretty favorable environment here for severe weather with these dew points as well. What's also going to be pretty impressive, well, the other stuff is not really that impressive, but what's going to be the most impressive part is the winds in the upper levels. We'll check out the 850 millibars, which is where your low jet is located. Now, some of the other models are much more aggressive here. So, and I think the Hermel is the least aggressive when it comes to 850 millibar winds, which is your low jet. But still, regardless here, it still shows pretty strong low jet winds. I mean, really, for good low jet winds, really 40 knots is really all you need. but we're getting values close to 80 in some spots, and that's pretty darn high. I mean, that's some pretty strong low jet winds. Your squall line is located right here, and whenever this trough becomes negatively tilted here deeper into Wednesday evening, you'll begin to notice that some of these the lava jet will begin to get a little bit stronger as well as soon as it becomes a little bit more negatively tipped, which you can see right here as we get deeper into the overnight hours. You start to see some higher numbers begin to show up. Like right here, for example, here it's got up to 90 knots. Some of that is from a thunderstorm as well, which kind of gives you an indication that significant damage winds will be possible as well. And you can see here as we get deeper to the overnight hours, you can still see some pretty high numbers. And they're also pretty widespread too here. Widespread 65 to 75 knots out there as well. But really at this point here, instability values really back off, especially you get further north here. Really, the main focus will be much farther to south where we have better instability values as well. And like I was talking about here, when we get negative tilt trough, which will go up to 500 millibars, which we do expect the trough to become negatively tilted sometime Wednesday evening. And that's going to help bring in stronger lift and also at the same time, stronger winds in the upper levels as well. And then again, winds in the upper levels are going to be pretty impressive, which you can see here towards Wednesday evening. You can see here where your black ones are located. This becomes a negatively tilt trough at that point as well. And that's going to lead to some stronger winds here. What you can see are 500 millibars. So you got some pretty strong winds, up to 115 knots. Those are some pretty powerful winds up at 500 millibars. So this really kind of tells you here that there's a lot of wind energy up there. And the storms don't have to build up that far to bring some of those stronger winds down to the surface as well. And that's why the instability is a big factor in here, because higher the instability values, stronger the storms. And with stronger storms, it's able to pull down some of those winds the upper levels a little bit easier. So that's why this is a very concerning setup because of the instability values. And like I was mentioning earlier in the video, that higher instability values, which some of these models are under instability values, can lead to more significant severe weather. It's not going to take much instability to get strong severe storms going in this type of environment, as the wind energy of how much we got is going to be very high. In some parts of the atmosphere, 850 millibars and some of our millibars could reach to record levels as well. Which if we check out the reflectivity to see how the squall line will look like, you can see here how these storms do form across Kansas there. And there could be some significant severe storms there as well. Well, actually not significant. That's the wrong wording. Some strong severe storms. That's the right wording. And you can see they do get a little bit weaker earlier in the day, but you do notice here how they become a little bit more organized. You can see here at this point here, we're in kind of the early afternoon hours to mid-afternoon. Here's your squall line here getting its act together. And look how far north this goes here. If I move that out of the way. Look how far north this squall line could get. And you're starting to notice these black circles begin to show up. That's an indication for the possibility for some rotating updrafts as well. Some of those stronger rotating updrafts, which we'll check out that swath map here in a little bit. But you look how far north it goes. It could possibly go as far north as Central Illinois, and that could extend all the way down into Mississippi. I mean, it's a very long squall line here. You can see here now. One thing I do notice here that could be a limiting factor here, especially later down the road, is that it tries to develop some storms out ahead of the main squall line as well. We'll have to wait and see if that does occur, but some models do indicate that as well, which, excuse me, that can disrupt these storms here along the squall line as well. And you also still have to pay attention to those storms, because any of these scattered storms here could become organized, and they do have a better opportunity to produce tornadoes, given the fact of how strong the wind shear would be. The wind shear values will be nearly off the charts here. And then as you kind of get deeper into Wednesday evening, your squall line is still visible here at this point here. It still extends from Louisville, Kentucky, and it goes all the way down into parts of Alabama, and still, Even with a lot of rain out ahead of it, this squall line can still contain damaging storyline winds as well, which if we do check out the wind gust, there's a couple points here where it does indicate some of those stronger wind gusts for some of these storms as well. You can see there's a little tiny area right here. There's another area right here where we could possibly see strong to severe wind gusts as well, which there you go right there, 53 knots. That's pretty close to severe wind gust territory in miles per hour. If we move this further to the south here, if we could get there, there we go, and go back to reflectivity, because as we get further to the south here, you will notice here some of these storms here become a little bit more discrete here or more of a broken line. And those are the ones that have the better opportunity to produce tornadoes, as some of those could be strong as well. As you can see here, by Wednesday morning here, you're starting to see that squall line become a little bit more organized. There's also some convection out ahead of this well, which may help limit, but you can see here as we get deeper to the afternoon, then that's when it really goes on. You start to see some of these little bowing segments here and there. That's where we could possibly see damaging storyline winds, and some of those could be significant as well, close to hurricane force winds as well, given by how much wind energy we got with this setup here. You can see here as they continue to move off to the east, but also at the same time though, you can see here it becomes a little bit more of a broken line, and some of those could become supercells as well, and that's where you do get that better strong tornado potential. But it doesn't take too much longer though, because as we get later in the day here, it does become a little bit more of a squall line as well. But even along the squall line here, we could still see QLCS tornadoes. But the thing about with these QLCS tornadoes, they'll likely last a little bit longer, given by the very large hodographs. You also have a very fast forward speed on these storms. Some of these storms could be moving about 60 miles per hour, somewhere around there, about 60 miles per hour. So these storms will be moving very quickly as well. And here's a look into your updraft helicity here. You notice here, there's a lot of them out there. And this is indicates for the possibility for rotating storms. And higher the number, stronger the rotation would be. And there are some stronger circulations out there. And that could lead to an indication for some rotating storms. And then again, with some of those higher numbers, that's where it could possibly see tornadoes. And some of those could be strong as well, especially some of these higher numbers. Now, this is just a simulation. It's not going to look exactly like this. But this kind of gives you an idea of what we could be dealing with here. You got a squall line of storms that roll through that has the possibility for damaging straight-line winds. Some of them could be significant. And you also got the possibility for rotating storms. And you can see here, then again, a lot of rotating swaths out here. There's a lot out in this area. And that leads to an indication that there could be a lot of circulations along this line here. And some of them could last for a long period of time as well. And some of these tornadoes, if they form along the squall line, could be strong given by those very large hodographs out there as well. Which, if we check out the significatoria parameters, and we'll check out a couple hodographs out there, which will take a minute to load. You can see here earlier in the day here, you got some pretty high significatoria parameter numbers. Really over a 1, conditions could be favorable for tornadoes, but when you get over a 2, that's where you could possibly see strong tornadoes. Which if we go into central Louisiana, which at this point here, some of these storms could be discrete. And you can see here, there's the lap rates are not very strong here, which could lead to a little bit of a messy mode in some of these areas further to the south here. But wherever that squall line does begin to catch up, we might be able to knock off that messy mode just a little bit. But in the upper levels, there is a pretty good elevated mix layer. But when you get further to the south here, between 500 millibars to the surface, it's a pretty saturated column right there. And that then again could possibly lead to a little bit more of a basic mode type of scenario. However, if you do check out some of the other ingredients like instability or CAPE, There's plenty of cape. Wind shear is also on the stronger side. And look at your hodograph here. It's a pretty large hodograph as well. So we'll have to wait and see if some of these storms here could get organized, because if it can, despite with messy mode, those ones have the potential to produce damaging winds, maybe some small hail, and also tornadoes. So some of those could be strong as well. And watch what happens as we get deeper to the day here. Now, wind shear values do begin to back off a little bit, but when wind shear values do become to come back up a little bit, you notice here a little bit further to the south here, those wind shear values, or I should say significant torque parameter values, do become to back up again. But let's go back just a little bit here. Let's go near peak time heating. Let's go to the Tennessee-Mississippi border. You will notice here that you got strong surface-based lap rates, and that can actually help with the damage wind threat. And you can also see at the same time here at the surface here, anytime when you got your temperature line and dew point lines spread out of each other towards the surface, that can indicate the possibility for damage winds as well. And I believe that's called dew point depression, if I'm correct. And usually when you get dew point depression, that indicates the possibility for damage with straight line winds as well. And also, by the way, your hodograph is pretty large here. It's almost off the chart here. And this indicates very fast moving storms. And then again, storms could be moving up to 60 miles per hour. So if you do get under a tornado warning, you don't have too much time here, as these storms here will be moving very quickly. Let's go and move our area here to the southeast here, because there's some pretty good significant torque parameter values as we get farther to the south here as well, especially later into Wednesday evening. You can see here how some of these significant torque parameter values do begin to go up, especially in parts of southwestern Alabama and southeastern Mississippi. And so if we do check that out, a little bit better elevated mixer in these layers in this area in here. But lap rates is on the weaker side, so there's still that potential for a messy mode. And that could be your bust potential a little bit further south here. Said you get so many showers of storms in the area, and so many storms could not get organized, you may not see that significant tornado potential. At least it won't be as high anyway. And you can see here, if we check out some of the other ingredients, story to felicity values between 400 to 500. There is some wind direction of high. The hodograph is also pretty favorable, and there's also a decent amount of instability. So then again, if any storms can get organized here, um, those ones will have the better potential to produce tornadoes. And some of those, then again, could be strong as well. Wind shear values are going to be pretty high in this area, in this area as well. And you can see here how that could go into the overnight hours, and you do notice here how some of those numbers do pick back up again. And like I was talking about in the early part of the video where we do have those wind advisories, it's going to be pretty daggone windy. Anytime where you have a sharp pressure gradient, there's going to be a low pressure, or I should say a high pressure system off the southeast coast. At the same time, you're going to have a strengthening low that's going to move off to the northeast. In between there, we're going to have a tight pressure gradient. The isobars are going to be close together, especially if you get sunshine out. That can also lead to even stronger wind gusts as well. And when you can put those together, you can see some pretty strong wind gusts at the surface when you get those together, which you can see here from the HER model. Widespread wind gusts anywhere from 40 to up as high as 50 miles per hour. But when you get to the closer to the squall line, you could possibly see wind gusts up to 55, maybe even close to 60 miles per hour. And that's closer to high wind warning territory. So even if you don't really see much way of severe thunderstorms, you'll likely experience some pretty strong wind gusts. And that can cause the possibility for isolated power outages. Definitely be sure to, for some of your outdoor stuff, maybe chairs, or a grill, be sure to time down or bring them inside, because these winds here are likely going to be blowing them around, stuff like that. So definitely be sure to do that. And as we get deeper to the overnight hours, they do begin to back off here. But I still do believe those winds are going to get strong again as we get deeper to the overnight hours, especially when that level jet really begins to kick in as well. So that's also another thing we really have to pay attention to as well, is these very strong wind gusts outside of some of these showers and thunderstorms as well. And you can see here how, if we get into Thursday here, how they move into parts of the eastern U.S. as well, especially up into parts of the Northeast. But anyways, guys, that's all for you guys today. Hope you guys enjoyed this video. Guys, like this video, hit that like button. If you're new, like my channel, hit the subscribe button, hit the bell notifications so you never miss an upload. If you guys have questions about this, put the comment section down below. Alright, you guys questions. I will see you guys in the next video. Goodbye and have a good day.